So we're looking at the distance formula today. The distance formula. We looked before at the idea of gradient, which is like the slope. Sorry about that. It's okay. Between two lines, like how steep is it? Is it a little bit steep or really steep, or is it going down? We looked at that. That's gradient, right? And now we're looking at something which we're quite familiar with, like how far are things apart? That's a simple question. That's all the distance formula is, okay? Now, it's a really awkward, hard to remember formula, but I hope that as I go through this, I'm going to be able to convince you that it's actually not that awkward, and if we go through it, it'll be quite easy to remember if you know why it exists. So, let's have a go. You don't need your calculator for this, but I think we can give it a go. If I just gave you this triangle, okay? Two sides, shorter sides, 5 and 12, right? What's the distance along this line here, the hypotenuse?
A squared plus b squared.
Ah, good. Okay, so let's write this down, and then we'll get a value at the end. Okay, so I normally would write this: a squared plus b squared equals c squared, and the reason for that is Pythagoras' theorem. Okay, but in this case, what are the little a and little b and the little c? Well, I guess you could call this one A, that's one of the shorter sides. You could call this one B, another one of the shorter sides. And that would make this hypotenuse the C, right? So I've got like an A and a B and a C. So if I substitute all of those pieces in, right? Here's what I look like I'm going to get. A squared, that'll be 5 squared, which is 25, and then plus 12 squared. You okay with that? Now, rather than call this C, I'm going to just name it by this length here. It's called AB, the distance from A to B. That's AB. Okay? So I'm going to call that AB squared. You happy with that so far? Okay. Now, I know you can simplify this. I know you can simplify it, but I'm not going to do it just yet, and you'll see why in a second. What I am going to do, though, is I'm going to do two things. I'm going to switch these sides because I want to know what AB is. Okay? So I'm putting this guy over on this side. The other thing is, to get rid of this square root, square. I don't want it squared. I'm going to take the square root of both sides. Okay? So watch this. So how do you feel with that? Does that make sense? Is that alright? What have I done? Well, you will in a second, but you don't need to just yet. Before we concentrate on what the number is, I want to see how we get that number. Okay? Alright, now, are you comfortable with this idea, with the line I've written? Is that okay? Yeah, not good? Okay. There's one more thing I'll add. Oh, sorry, Sabet, do you want to ask a question?
Yeah, just on the second line, I'm confused about the AB part.
Yeah, AB is this length here. It's the hypotenuse.
It's just
It just means A plus
From A to B.
Yeah. Okay.
Is that okay?
together, is that what
Yeah. Tom?
I'm confused about like why you have to put the square root.
Yeah, okay, right. So Pythagoras' theorem is not just about the sides of the triangle, it's about the squares of the sides of the triangle, right? But what I'm trying to ask is, well, how far is it from, what's the distance from A to B? I don't want the square of the distance, I just want the distance, right? So to get rid of the square part, that's why I take the square root, okay? There's one more thing that I'll add on to the side, and you can add it too. I have to say this. The reason why is because actually when you take the square root, do you remember this? When we were solving equations, I'll just put this up in the corner. If I gave you this equation, x squared equals 25, okay? What do you think the answer is? There's a number, you square it, and it'll give you 25. And the answer is, it's 5, right? But that's actually only one of the answers. There's two answers. There's plus 5. There's also negative 5. Do you remember this? Plus or minus 5. We looked at this under algebra. Anyhow, the point is that there are two solutions, but I only want one of them, the positive one, where it's greater than 0. Okay? The reason why is because lengths have to be positive. You don't measure out a table and say, oh, this is about minus 3 meters long, right? You just say, well, it's 3 meters long. So I only want the positive value. All right. Great, we've written that. So now I want to work out what these numbers are. 5 squared, I actually just worked that out. It's 25. 12 squared will be 144. Very good.
And then equals 13.
So that's equal to the square root of 169, and that actually happens to be a square number. It's the square of 13. So therefore, it's
That was working out.
13. Yes, I know. And I emphasize this to you guys all the time, that you shouldn't skip steps. Sometimes when you come over and show me your work and you're like, I don't know what's going wrong. Part of the reason why things can go wrong and you don't know is because you haven't written down the steps. Okay? So this helps you know exactly what's going on. Hey Ash, what's up? Who are you looking for?
Brittany Ross.
Brittany, yes. Where does she have to go?
Miss Adam on the HSI staff meeting.
Okay, thank you. No, it's okay. I'm gonna cut it anyway. So just whatever. Okay. Whatever. All right. One very last thing before we leave this particular question. AB is a distance. It's a length, right? Now, all lengths, all distances have to have some kind of units attached to them, right? Because if you said, hey, I'm going to walk 20, that could be a very short distance or it could be a very long distance depending on the units, right? It's like, are you walking 20 meters?
It doesn't say that.
Or 20 kilometers, okay? Good. Now, since it doesn't say, you should say units. That's all, okay?
Would you get marked then? Well, you do it.
You might, yeah. In the HSC, I can tell you right now that there will be a question where they're looking for you to get the units right. Okay, so just write that down. It's a helpful thing.